So now I'll talk about real gas behavior. So here a reality check. The real gas deviate from ideal behavior due to the molecular size and intermolecular force. So Van der Waals equation, that P plus AN square by V square by V minus NB by nRT. So A is account for intermolecular attraction and B is accounts for molecular volume. So now here if I rearrange that Van der Waals equation, so that will be P is equal to nRT by V minus NB minus AN square by V square. So two correction terms modify the ideal pressure. So now here for carbon dioxide, A is given 3.640 atm liter square mole square by mole square and B is 0.04267 liter by mole. Okay, so for carbon dioxide that A and B is given. Now here is the one example. Compare real gas versus ideal gas pressure 2 mole carbon dioxide at 300 Kelvin in 5 liter. So now here Van der Waals real gas Van der Waals equation. So P is equal to nRT by V minus NB minus AN square by B square. So now first term we can plug that N is 2, R 0.08206, T is 300 and V is that 5 liter minus 2, that is mole, and B value already given in the last slide, so 0.04267. so that will be the first term, and if we do the calculation that will be 10.014 atm. And second term, that is AN square by V square, so A value is 3.640 into 2 whole square by 5 square, so that is 0.582 atm. So P real, so 10 minus 0.14 minus 0.582, that will be 9.43 atm. And ideal gas, so P is equal to nRT by V. If we plug N is equal to 2, R is equal to 0.08206 into 300 divided by 5. So P ideal is 9.852 atm. So ideal gas overestimate pressure by 4.5%. So P ideal is 9.852, P real is 9.432. So that is our ideal gas overestimate pressure by 4.5%. So key insight, real gas show lower pressure due to the intermolecular attraction. So next is example is the compressibility factor analysis. So compressibility factor quantifies deviation from ideal gas behavior. So Z is equal to PV by nRT. So Z, when Z is equal to 1, that is perfect gas behavior. Z less than 1, attractive force dominate. So here molecule are very closer, and Z greater than 1, repulsive force dominate, means molecules go away. So now for carbon dioxide example calculation, so we know that P real is 9.432 atm. Okay, and then if I plug that PV is equal to nRT, so P is 9.432 and that V is 5 liter, then N is 2 and R is 0.08206 into 300 is T. So after doing the calculation we will get Z is equal to 0.958. Okay, so means Z less than 1. Confirm attractive force dominant for the carbon dioxide under this condition. So that way we can easily calculate the compressibility factor.